Hey guys, it's Mr. Post, and on today's video, we'll be practicing completing chemical reactions. Okay guys, what we have in this case is predicting the product, and I'm going to ask you to actually tell me what's going to be on the product side. You're actually going to predict what is produced. And so once you look at this reaction and say what exactly is going on. First, let's classify this. This is a decomposition reaction. In a decomposition reaction, the compound initially is going to break apart. And it's going to break apart into its atoms that, or I should say, the elements that make it up. And it's made up of aluminum, and it's also made up of fluorine. So basically what we're looking for here is, in a decomposition reaction, for when an atom breaks apart, you just write down the elements that it's made out of. One of the things you want to double check here is the subscripts, okay? Whenever you make a product on the other side, on the right-hand side of the reaction, you always make brand new subscripts, meaning the 3 and the 1 from the Al1F3 here, they always stay in the reactants. You make brand new subscripts over in the products. Now, I've used a 2 for fluorine because fluorine is a diatomic molecule. It exists as an F2 state. And I want you to see there are other elements that actually exist as diatomic molecules, just naturally occurring. They have a 2 next to them, such as F2. And we learned about this in covalent compounds. Shouldn't be brand new to us. And I want you to see that aluminum does not appear on this list. So therefore, it's not a diatomic molecule. It is just going to be 1 for aluminum. So Al1 plus F2 is the product, what is produced here. Another thing I want you to see is that this reaction is not balanced. The purpose of this video is not to balance the reaction, but just to predict the product. Alright guys, here's another example. Let's check it out. First thing I want you to see is what kind of reaction is it? Maybe you want to take 2 seconds, try to guess what kind of reaction this is. Alright dudes, this is going to be a synthesis reaction where 2 elements are going to come together to form 1 compound. And the possible combinations are really going to be aluminum and chlorine. Like I said in the last slide, you leave the subscripts, like the 2. Alright, the 2, that stays over there on the left-hand side of the equation. When you make a product, you have to make brand new subscripts. And what I've made here is an ionic compound, aluminum and chlorine. It's going to be aluminum chloride. But I want you to see is that you need to take the charges of 3 plus and 1 minus and cross them. So the 1 minus goes down here as a 1, and the 3 goes over here as a 3. And the product, I'm just going to simply draw the product down below here, is going to be Al Cl3. Okay, so that is what is produced here. Once again, the goal is to produce the product. The product is the substances that appear on the right-hand side of the equation. So far I've done a decomposition reaction. I've just done a synthesis reaction where 2 elements combine together to form 1. I'm now going to look at a single replacement reaction. Let's go ahead and predict the products here, guys. Lithium is going to replace calcium. Lithium is a very active metal. We learned in a previous lesson, the higher in activity series you are, the more active of a metal you are. And I'll just give you a little bit of insight here. Lithium is definitely more active than calcium. So calcium and lithium are going to trade places. So that means calcium is going to be by itself. And what I'm going to have is a new compound, and that's going to be lithium. And I'm also going to have oxygen. Remember what I said last time, guys? All the subscripts stay on the left-hand side in the reactants. When you make products, you make brand new subscripts. Now, I'm kind of good so far, all right? Calcium always appears as a Ca1 in nature. That's cool. Now, how about over here? I still have to deal with lithium and oxygen. Now, lithium has a 1 plus charge based on the periodic table. Oxygen, a 2 minus charge. I want you to cross the charges. This is an ionic compound. Let's cross the charges. The 2 goes down there, and the 1 I crossed over here. So the new product is going to be, if we're going to write it nice and neat, is going to be Ca. Ca1, we just ignore the 1. Ca plus lithium with a 2, and then oxygen. The 1 we do not write. So it's going to be calcium plus lithium oxide. Alright guys, this is an example of a double replacement reaction. In a double replacement reaction, what I want you to see is that you can either choose this, the metals or the non-metals. I'm going to choose the metals, and I'm going to say the metals are going to trade places. Okay? And Mg and Li will trade places, and they'll have two replacements going on. You could have also said, the non-metals trade places too. That's the same thing, just choosing different elements. But for now, let's stick with the metals. Li is now going to leave oxygen and be joined with chlorine. And I'm going to write that on the other side here. Li is now going to be with, not oxygen anymore, it's going to be with chlorine. Awesome. And I'm going to draw a plus sign. The plus sign in this case doesn't mean reacts with, it means and, because I'm producing lithium chloride, and now magnesium is no longer with chlorine. Magnesium will be with oxygen. Alright guys, last thing is the subscripts. Let's cross the charges here. These are ionic compounds. I have a 1 plus and a 1 minus. And a 1 plus and a 1 minus, even when you cross them, reduce down to 1 and 1. So down here, I'd see a 1 and a 1 when I cross the charges. And how about magnesium and oxygen? Well, it just so happens that I'm going to see a 2 plus and a 2 minus for oxygen. And when you cross the 2, you end up with a 2 to 2 ratio, which does reduce down to a 1 to 1. So what I have here is lithium chloride as a product. The subscripts are both going to be 1s. And I also have magnesium oxide as a product, and the subscripts are going to be 1s because the 2's reduced down to 1s. The very last thing we're going to look at here is a combustion reaction, and these are probably the easiest reactions to predict the products for. In a combustion reaction, the products are always going to be CO2 and H2O. Okay, that's the answer every single time you see a combustion reaction. The answer is always going to be the product is CO2 and H2O. Okay, guys, that's all for tonight. Hope the lesson was helpful. Thank you so much for tuning in. Be good.